So we were discussing about uh, different methods of data security, like as we discussed that there are uh, two different ways for the data security. Uh, like for example, to ensure the data security, we apply different security features. So like we provide the confidentiality to the data, we provide the uh, integrity to the data, availability to the data, and non-reputation. So these are the different security features we provide in order to secure the data. So as far as the confidentiality is concerned, that means that the data should not be disclosed to unauthorized users. So that is called the confidentiality. So to maintain the confidentiality, we apply different methods. So the most important method to apply the confidentiality is we apply the encryption on the data. So as far as the encryption is concerned, there are the different ways of uh, applying the encryption. Like there's a symmetric method, there's an asymmetric method. Or for example, there's a private key crypto system or cryptography, and there's a public key cryptography. So in symmetric crypto system or cryptography or symmetric encryption, we say that when there's the same keys used on both sides from sender to the receiver. So when the sender encrypts the data and receiver uh, decrypts the data, they use the same key. We call that key is a private key. So then that means it's a type of a private key encryption or symmetric key encryption. And we have the different examples of we gone through different examples of the semantic encryption. Like for example, there's a DES algorithm, there's a AES algorithm, and some other types of cryptographic uh, semantic encryption algorithms. So we have in the same way, we have also different types of public key crypto systems or public key crypto algorithms. So we uh, we say that why it is called the public key crypto system. Uh, Public key cryptography or public key encryption is where we have a different key for the encryption and different key for the decryption. For example, if we use a public key for encryption, then we use a private key for decryption. So if we are using the public key for encryption, that provides a feature that is called secrecy to the data, that is called confidentiality to the data. If we uh, if we encrypt the data with the private key, that provides authentication to the data, because it is encrypted with a private key, and when it is received by the receiver, so it authenticates that it is encrypted with the private key. So that could be, so that's why it's coming from legitimate user or the authenticated user. So that feature is called authentication. And the public key cryptography or public key algorithm, encryption algorithm, also used to exchange the keys between a sender and receiver. So it's also used for the key exchange as well. So these are the different functions we discussed for the public key cryptography, and we also gone through how the algorithm uh, to calculate or to generate the keys for the public key cryptography, public key encryption. Like for example, we discussed the RSA algorithm, which is an example of the public key encryption. So we discussed the algorithm for that and how that algorithm is used to generate the keys for encryption and decryption. So today we further discuss about uh, if the if the keys are generated, so how we can manage those keys. For example, there's a public key cryptography or public keys which are generated by the sender, for example, or by the receiver, for example, to send to the the senders, so that they encrypt the data, and then that's received by the receiver to decrypt the data using a private key. So how that is actually distributed, how these keys are distributed to the senders. So there could be different ways of distributing these keys to the users, to the users who will encrypt the data, and then the receiver receives that data and then decrypt that data using a private key. So what are the different methods which are applied to send the keys to different users? Now there are the different ways which are used to send the keys. For example, like here, there's a method that is called as a public key announcement, a public key availability directory, a public key authority, or public key certificate. So these are the different ways of sending the data uh, to the senders or to the users which are going to encrypt the data, and then after encryption they will send the data to the other users, and they receive the data and decrypt the data using a private. Now, what is the function of the public key announcement? How the keys are distributed through this method? Actually, what happens there in this method, the public keys are broadcasted to every user in the system, every user in the network. So they send the data, they send the public key to the users which are sending the data. So every user in the system, or every user in the network, is receiving that key, that the public key to encrypt the data. So if we are using such type of methods, that we broadcast a key to every user in the network or every user in the system, so there's a possibility that there could be the intruder in the network or in the system, and he may receive that key, and he will encrypt the data, and then send to the receiver. So in this way, in order to protect the uh, the system, or in order to protect the network, or in order to protect uh, the, the user from such type of attack, so we need to apply another method, so that we can ensure that the key which is received by the user, that is a legitimate user, and that is not an intruder, or that is not an attacker. So we need to try, we need to authenticate, we need to send the keys to only the authenticated users, which are uh, which are verified users, and they can be able to receive the key, and then they encrypt the data, and then they send the data to uh, the to other user, or receiver, and then it decrypts the data, it decrypts the message. So there's another method that is used to fix this problem. For example, there's a method that is called the public key uh, av- uh, available directory. So it uses actually a directory here to register different keys. So when it registers different keys in the directory, so the users can access from their directory to get the keys. So uh, uh, rather we send the data, or rather we send the public keys to every user, or broadcast the public keys to every user. So we actually set the directory here, and register the public keys in that directory, and then from that directory the users can access the public key. And in this way, the only the users which is given access to that directory, then they can be able to get the public keys from their directory. So that's why we say that if we compare this with the previous method, so in the previous method every user was getting the public key, and in this way there was a possibility that there could be the intruder which has received that public key, and then he can use that key to encrypt the data. So to secure that or to fix that problem, so we can have a directory where the different keys are registered. And then from that directory, the different users which are given access to the directory, and then they can access the public key from that directory. Now still there's a possibility that because uh, we are actually having different users having different privileges, and there's a possibility that there could be some users who does not have privilege to access the directory, and they can also access the directory and get the public key from that, and then they encrypt the data, and then their data or that message is decrypted by the receiver. And so in this way there's a possibility of tampering, or there's a possibility of the forging of the message. So there's a possibility of the masquerading. So because there are the different privileges given to every users, and there's a possibility the user which has not given the privilege or which is not giving the permission to access the directory, so he may access the directory and then he can get the key. So to fix this problem, we apply another method, like for example that is called as a public key authority. So we actually give the particular uh, permission, particular control to the user, that these particular users are can only be used, can only be able to access the particular the directory and get the public key from that. So that's why we say that this type of method, we say that we give the authority, give the permission to only the users which are given access to access the directory, and they can get the public key from that directory. So that's why we say that this type of method is actually called the giving permission, giving permission to only the users which are used to access the directory. So in this way we can manage the key these by these different ways. So with the help of these different ways we can manage, or we can distribute the key to the users, and we can apply different permission to the user, that which users should can access the public key, and which users cannot access the public key. So we define different permissions. We can define different privileges. So in this way we can manage the public keys, or we can control the distribution of the public keys, so that only the authorized users can have the access of these public keys, and then they can only be able to encrypt the message, and then they send the message to the receiver, then it will decrypt the message. So so these are the different ways which are used to distribute the keys to the different users, so that they encrypt the data. So this is further explained by this figure as well. For example, there's a user uh, A, and there's a user B. So if he want to encrypt the data and then send the data to other user, so before that he will send a request to the authorized organization or authority to give the public key. So it will send the request to that and then it will send the public key, receive that request, and after that it will send the public key to the user. So actually it will also uh, define a time limit for that. For example, if particular key is given to the user as a particular limit, for example. So up to that limit he can use that key, and after that then he can request again to the public key authority, or the authority to give the key, and then he can encrypt the data with that key and then send to the user. So in this way, there's a possibility that there could be an intruder in between the user and the authority which is sending the public key, so he can get the key and encrypt the message with that key. And for example, if it's not given a particular time period, it's a possibility that he can reuse that key for another message and send that key to the user, and encrypt the data, and then it send that message, encrypted message, to other user. So in order to protect that, so we are using a time limit for that, and then it will send the data to other user, for example. So it consists of the identification of the user, and the nouns is used here, that is a digit which is actually used to authenticate a particular message, for example. So it is also authenticated by a nouns, a number, or a digit. So it will send a message, send an identification to other user using a key that is received from the public key authority. And in the same way, the user B, for example, here it will also request for the public key from the public key authority, and it also defines a time period for that to protect that message from reusing uh, by the intruder or by the taker. So it will send the request to the public key authority, and then public key authority will send the key to the user. So after receiving the keys by both the users, for example, user A and user B, now they are able to encrypt the data, to be encrypt the data and send the messages to each other. For example, here, after receiving the key, it can send send the nouns, for example, which is used to authenticate the user. So it will also send that nouns, which is received from the user A, and send the message to the user A, for example, to authenticate itself. So in this way, the receiver, which is receive the nouns from the user, and it is sending the same nouns to the user A to authenticate that message has been coming from legitimate user. And in the same way, the user A will send that particular nouns to the user B, so that he can also authenticate itself that he's a legitimate user, which is sending the messages, sending the messages to other user. So in this way, they authenticate each other, and after authenticating each other, they can now they can send the messages to each other. So in this way, we can securely send the public keys to different users, and then after sending these public keys, they can also authenticate each other, and after authenticating each other, they can be able to encrypt the messages and send the messages to each other. So in this way, this method is used to provide secure distribution of the public keys to different users. So there's another method, as we discussed. There are the public key certificates, for example, which are used to authenticate the users. So they are created by the public key authority. When they create these certificates, and then they send the certificates to the users, once they receive these certificates, that means they are verified users. Whenever they send the data to other user, so it will attach that certificate with the data. And when the receiver receives that message, so it verifies that it contains the particular certificate which is received from the certification authority. Then it verifies it is an authorized user, or it is an authenticated user. So in this way, that different users are verified users by having the certificate, or sending the certificate with the message to the receiver, and then the receiver verifies the message by verifying that particular certificate was received from the certification authority. Now, how these different certificates are sent it to different users. So this figure further explain that how these different certificates are sent it to different users. For example, here the user A want to receive the certificate from the certification authority. It will send request are the request that consists of the private key or encryption key, which is sent it to the certification authority. Then the certification authority will generate a certificate using identification of that user, and also the private key which is received from the user, and then it will encrypt that using a session key, which is used to exchange the messages between the user and the certification authority. And then it will send then it will send that certificate to the user. And after receiving that certificate, now he can send the message, and with the message he can also attach the certificate, so that a receiver receives that message and verifies that message has been coming from legitimate user. So in the same way, there's a user B. He can also request the certificate from the certification authority, and then certification authority will give or send the particular certificate using identification of user B, and it will also contain a private key that is received by that is sent by the user B to the certification authority, and then it will encrypt that with the session key, which is used to exchange the messages between certification authority and the user B here. So it will also, you can see it is also using a time limit for that, because the use of the time limit or validity of the certificate is that, so it defines a particular validity or period of the time that that particular certificate will be validated. So after that it will be reissued to the user. So this will help in the way that if there's a possibility that there could be an intruder in between user A user and certification authority, or certification authority or user B. So there could be possibility that there could be an intruder in between here, and he can get that certificate and again send to other user to authenticate that to masquerade itself that if it is a legitimate user, and send the message to other user, or send the encrypted message to the other user. So in this way we can also protect the message or protect the certificate from using of the intruder or the attacker. So the attacker or the intruder cannot reuse that particular certificate to send the data or to encrypt the data to other user. So these are the different ways we discussed that how we can distribute the keys to different users, which are used to send the data, which are used to send the data between sender and the receiver. And before sending the data by user A and to user B, so they will receive the key from the certification authority. So after receiving the key from the certification authority, they encrypt the message using this key. Or for example, they can also get the certificate from the certification authority, and then they can send the message, send the certificate with the message, and that certificate will verify that that particular message has been coming from the particular certification, a particular user, a verified user which has got which has received the certificate from different user uh, from certification authority. Okay, so have you any question? Have you any question?
सर प्लीज सर उर्दू में पढ़ा।
सर ये चैट तो बंद कर दे, पता नहीं कौन नाम चेंज करके आ रहा है हमारे बार बार, अच्छी बात नहीं है सर ये।
So you can also ignore that. Just focus on the lecture, and then if you need
सर
to.
जो लास्ट में आपने बताया उसको थोड़ा रिपीट कर दें सर।
सर आप उर्दू में पढ़ाएं सर। सर प्लीज सर।
What
एग्जांपल ना वो एग्जांपल
what
समझ
you
नहीं
want to
आया
ask?
सर। प्लीज एक्सप्लेन दैट एग्जांपल, आई डोंट अंडरस्टैंड।
So you mean public key certificates?
यस सर।
So there are as we know that to send the data to other user, there's a method which is used to encrypt the data. As a encryption method is used. So for encrypting the data, we can have an encryption key. So here for the asymmetric encryption, we are using the public key to encrypt the data, and that will encrypt the message to and then send the message to other user. So actually, the thing is that there's a possibility whenever the keys are distributed to other users. So there's a possibility there could be an attacker, there could be an intruder, which can receive that key and then use that key to encrypt the data, and it will act as it is a legitimate user, and it is sending the message. It will, after receiving that, after getting the public key, it will encrypt the message and send that message to the user. So to fix that, to protect uh, the keys from an intruder to receive or to get that, so we need to authenticate that the keys which are received by the legitimate user. So there's a we discuss different ways that how we can authenticate or verify that the key which is received by the authenticated user. So there are the different ways. So one of the way to authenticate that particular key is public key is received by only the authenticated user is a certificate by the creation of certificates. So the certificates are public key certificates are generated by the particular certification authority. So which will generate the certificate for particular user. For example, if a user A want to send the data to the user B, so before sending the data to the user B, so he needs to have a public key. So for the public key, so he will replace that public key from the user, from the certification authority. So in uh, rather he's sending the public key, it will send the public key certificate, which also authenticate the user that the message has been coming from the legitimate user. If we say that if the public key is only send it to the user, so it is just only to encrypt the message. But if we say that if it is a public key certificate that is sent it by the user to the user B to send the message, so then it also authenticate the user as well, that the data has been coming from a legitimate user. So the legitimate user, uh, the authenticated user, that receives the certificate from the certification authority, and then this certificate contains the identification of the user and also the key which is used for encrypting the messages. So that that certificate is sent it to the user, and then that message is whenever any message is sent it by user to the user B, for example, so it will encrypt the message, or it will attach the certificate with that message, and when it is received by the receiver, so it verifies the message with that certificate that the message has been received, which is a verified message, and it contains a certificate which has been received, which has been sent it to the user from the certification authority. So that's why it's a verified message, and it can then decrypt the message and send encrypt the message again to the user A, for example. So in this way, this method is used to authenticate the user, which is receiving the public key from the certification authority.